Hey guys, so I so happened to actually submit an assignment which is an explanation of the collections framework in Java, and I did happen to make a 1 hour video instead of a 10-minute or a 20-minute video. So I thought this is going to be something that I should not just keep to myself and I should upload it on YouTube. The collections framework is it's a framework that makes many people's life easier, especially the competitive coders. Now, if you're given a problem statement to solve a particular question, you don't have to actually you have to just rather worry about the algorithm than actually worry about what data structure you're going to build, or what functions you're going to use. How do you build those functions? You just don't have to worry about that. You just suppose you want a stack, you're just going to import a stack and use the stack for your program, rather than worrying about, okay, let's construct the pop function, let's construct the push function. And we've skipped a lot of concepts again in Java. So let me know if you want a video for those beginning concepts as well, about primitives. And there's so many concepts that we skipped. We just directly skipped to the collections framework, and the very next topic after this would obviously be things like which is in your DSA. So let me know if you actually loved this video, and if you did, please comment it down below. It'll be very useful for me to actually see if I have to upload more content in this series. And consider liking, sharing, subscribe to your friends. I really hope some of my juniors actually get to see this video and hopefully find it useful. If you're learning Java, I just hope you learn Java the best way possible. And I will give, I can't give a guarantee, of course, but I will try my best delivering the best content as much as possible. And of course, I will take in feedback for, improving the platform and stuff. So go ahead, happy coding, and I hope you love this video. See you. Hey everyone. So this is the assignment that's been tasked me. I've been tasked to talk about collections framework. Allow me to share my screen, and hopefully this is a really good discussion that we're going to have. So the lesson that we're going to be talking today is collections framework, and the right set of audience, I'd say, for this topic is anyone who has an interest to learn Java, working professionals who are using Java in their industry, students from all walks of life. It could be 10th grade students, people who are studying in their pre-university, or even universities who offer Java as a course. The sources that have been used for this presentation is Java Point, Geeks for Geeks, and slides from several Indian and foreign universities. The main objective for this class is to, again, help one understand the several concepts behind the making of the applications of the collections framework in Java, the main why of the collections framework and why did it come into existence. The tools that will be required, it's a very good habit, again, to have a notebook to make small pointers in whatever you're learning. And of course, the slides will be providing you enough of information, but again, it's a very good habit to make small notes as and when you code, or it's obviously going to help. And you can also have JDK installed along with an editor, an IDE like IntelliJ or VS Code. The IDE that I will be using is IntelliJ. You can also use any online coding editor, and that would work. So that's it. You're ready to go. Let's give the green signal. So we're going to be talking about collections framework once again, and this is the set of events, or this is the timeline that is going to take place. We'll talk about first what are frameworks and how Java is using these collections, or what's the use of it. And we're going to talk about a couple of interfaces that comes above the collections interface, and we'll also talk about the user-defined functions that are provided by the collection interface. Now that's part of the collections framework. Then we'll code a couple of classes which use the collection interface, and we'll conclude along with uh, an application where we are using this ready-made collection interface. Now, framework is a real or a conceptual structure that's intended to serve as a support or a guide for the building of something that expands the structure into something more useful. This is once again the definition of a structure provided by Google. Now, if you see the picture of the tea, it just reminds me, suppose you're going to make tea every morning. You will have to mix this ingredients on a daily basis, right? Like sugar, tea leaves, some water, and whatnot, and some spices, some adrak, whatever, right? Now, this is done in a methodical manner, and you do it almost every day on a daily basis to a point where sometimes you will find it difficult to actually put all the right ingredients in the correct ratios all the time. And sometimes you might even tend to forget adding certain ingredients. Sometimes the sugar might be like 3 spoons instead of 1 spoon and might spoil your tea. You might have done it in a hurry, but again, it's not in the right proportions. Now, one morning you just come up with this idea of, taking a jar and then, mixing all these ingredients in a correct ratio and then storing it in the jar. And every morning from now on, or from that day on, you just come in, open that jar, put your tea, and mix the water and drink it. How convenient it becomes, right? So that's what a framework does. And Java frameworks provide a ready-made architecture. It provides a set of classes and interfaces which can just be imported and used so easily. And of course, it's optional. And the collections framework in Java is basically, it is a framework which provides an architecture to store, manipulate a group of objects. By a group of objects, it could be an array list, it could be a linked list. There are so many group of objects. It's used for a data which has several objects grouped together. So the Java collections basically help you achieve all the operations that you want to perform on your data, which is again the group of objects, such as searching, sorting, insertion, manipulation, and deletion. Java collection means basically a single unit of objects, and these can be, many interfaces in terms of list, set, queues, and even dequeues. But the classes which will be implementing these interfaces is what we're going to be using in our code, and that's namely, the array list, vector, linked list, priority queues, hash set, linked set, and tree set. The main ideology behind this F1 car is, again, to talk about this real life example of a framework wherein, the drivers are actually the most smart, or they have the most important knowledge about the F1 car more than the mechanics that built it itself. But does that mean the drivers sit and build their car and, drive for the race? They know their car better. Like, they know what are the weaknesses in their car. They know how to handle a car and stuff. But then the matter of fact is the drivers have to sit and focus on winning the race rather than worrying about how the car is made. And the making of the car or the design of the car is a part of the mechanics department, and that'll be handled. And of course, the drivers can give in their inputs as to, hey, so make this seat 5 centimeters more front or 5 centimeters more back. That set of inputs, of course, the driver can give. But then the main building is handled by the mechanics itself. And the driver, all he has to do is just drive the car and win the race. Provide certain inputs, drive the car, win the race. Similarly, in our problem statements or any programming concepts where we need to use such searching functions, sorting functions, or any form of structures, we're not going to create the structures in hand. We will be using these collection frameworks. and the set of classes that it provides. So, so is the hierarchy of the collections framework. The blue boxes that you will be seeing here is your interfaces, and the green ones are basically your class. Now you have the iterable interface followed by, which is extended by the collection interface. And extend basically is the solid black arrow. And implements is when a class implements an interface. That's represented by the dotted lines. The java.util package is what contains all the classes and interface for the collections framework. And there are many functions that's defined in the collection interface, which we'll be talking about soon, if you remember the timeline of the events. Let's just have a brief look on how the hierarchy exists in the collections framework. We have the iterable interface followed by the collection interface. The collection interface extends the iterable. Now, several forms of interfaces can extend the collections. The collections has a set of functions that's been defined, and other interfaces can extend to the collection interface and make it their own. So the list interface adds a set of functions of its own, separate from, say, queue and set, and that will add it to the collection interface functions. So suppose the collection interface has 5 functions, which is common to all the 3, which is list, queue, and set. The list will have an extra 3. The queue will have a separate 4, and set will have a separate 2. But all of these, the 3, 5, and 2 functions will have the common 5 functions that's been defined in the collection interface. So an extension is always allowed in Java. Now we have these concrete classes, which you can see below: the array list, the linked list, and the vectors, followed by the stacks. These will all implement your list interface. The priority queue implements the queue interface. The hash set implements the set interface. Now, the green boxes that we're talking about, which implements an interface, these are called concrete classes. Concrete means you're defining the function. Now, the list will just have the list is basically an interface which will just be a contract, and it will just have this add function. It has just the declaration of the function, the set of signatures, the functions that's being listed. It's a contract. These concrete classes sign the contract saying, okay, I will define these functions. The list interface says, suppose it has 5 functions. The array list and linked list, they implement the list. And they say to the list interface saying, okay, I see 5 functions they have listed. I will, make my own definitions of the interfaces that you want, and I will implement. And, they sign a contract of implementing all the 5 functions that's been declared in the list interface. So these concrete classes help you to define your structure. So that's the main reason why we'll be having classes for this. But again, it comes to the point where what's the why of this collections framework? If each class is implementing their own thing, why have an interface and all this hierarchy, right? So before we had the collections framework, we used to have a separate implementation for an array list, a separate implementation for linked list, a separate one for vector and array dequeue, and so on. And it was such that basically you had to implement it while focusing on your other problem statement or another application. Suppose you're working on a competitive coding. I had to create the array list by myself. I had to work on the sorting and searching functions all by myself. And along with this, focus on the problem statement itself. So that was a very tedious task. And it's an added task to basically make these implementations apart from your main goal, which is, solving the code itself. So, it helps us by providing a set of interfaces, and, it gives us also API calls like .add or, .remove, which will help us, or .get, which will help us implement such functions, to search, sort, add, remove and manipulate the data. All these concrete classes like, array list, vectors and stacks, they have these common set of methods like add and remove, right? Now that can be defined in the collection interface. That can be defined in the list interface rather than being defined separately for each and every class. So what is the object oriented programming principle that's been used in this list and concrete classes? I'm guessing that's correct. It's the data abstraction principle that's been used, wherein you're abstracted from the data that they're working on. Basically, different data structures can implement similar functions. So the interface helps with, it's a form of abstraction that you can do. So I do not want to make it a boring theory class, but these are the functions that's basically more or less listed in the collection interface. As I talked before, you have the add, you have add all. So the add is used to add a specific element, right? So an element could be, a specific type, could be an integer, could be a string, could be so on, several data structures. And this E basically, you need to use the wrapper classes. You cannot use primitives like int. You have to use integer. Uh, Again, like, that's something else itself. That's a separate topic itself. But there are several functions like add all. Add all is used to have a collection itself. So suppose you have an array list within another array list. So you have a collection within another collection. So that's where these functions add all and remove all is used. You have retain all, you have clear, you have size, which tells you the size of your collection, so on. So this set of functions is being now extended by, say, the list interface and your set interface and so on. And now the concrete classes will implement these functions. They will implement it, define the function so that they can be now used in your programs. So we're talking about just briefly the main interface that just comes right above the collection interface, which is your iterator interface and provides you the facility of iterating through elements in a forward direction only. The functions that's used is basically whether your collection has a next, if it has more elements, otherwise it returns false. And your next function is going to actually move to the next. And remove is used to remove the current element that's on top in your set of list, for example. The has next is used to check whether you have another element following. The next is used to actually move, and remove is used to remove. The iterable interface is again the root of all collection classes. The collection interface extends the iterable interface, and therefore all the subclasses of the collection interface are also going to implement the iterable interface. Now this iterator is basically used to iterate through these set of objects, right? So it contains only one abstract method, and that is your iterator method. And it returns the iterator over the elements of type T. T could be any form of collection. So let's talk about the main set of concepts. We'll be talking about mainly the list interface, and let's see if we can go into the hash and stuff. So the list interface is basically providing you the facility to maintain an ordered collection. It contains index-based methods to insert, update, delete, and search elements, and it also gives you the flexibility to have duplicate elements. We can store even null elements in the list. So this is where a list interface comes in more handy than, say, an array, because an array is a very static data structure. It's more or less in the static memory. It's stored in a stack. Versus all of this that we've been talking about, collections, this allows the user to actually dynamically, create and add and remove elements based on his or her interest. So that's being defined or stored in the heap memory, and that's one solid advantage for the user. He can add and delete elements as and when he should. The implementation classes for the list interface is array list, linked list, stacks, and vectors. And the methods of the list interface is size, clear, add, add all, contains, and equals, is empty, index off. Let's just start coding, shall we? Allow me to share my screen to the code. So the code editor that I'll be using is IntelliJ. Yes. So this is the framework. It's a very comfortable interface that's available. So the first thing that we'll talk about is the list, right? So how do we use the list? Now, the main thing to be kept in mind is we need to actually import java.util.list package to use this list interface. So I'll go ahead and do that. Otherwise, it's going to throw me an error. So this gives me the flexibility to create a list. This is how simply I can, import any form of collection framework and use it as and when I could. So let's create one. So list. As I said before, we're going to have to use wrapper classes. Now, it's again throwing an error because if I want to use an array list, I'm going to have to call in this class, the array list class, import java.util.arraylist. So now we've created an object, say list of classes, array list. Now this array list is implements the functionalities of the list interface. That's what we have to say. A simple program would be I've created a list of integers, right? So let's change the name of the list to numbers. It's a very good habit for variable naming to actually follow the convention, as in any variable that you're defining should follow the naming convention. It should be exactly what you exactly are trying to define. So number dot add, this was the most common thing that was defined in the collection framework. So I've done one. Let me add numbers 2, 3, 4. Yes. So there's another class called object class, which has the toString function. And what that does is it helps you print whatever you want, to be printed on the screen. Now this overrides, now since we want to print this collection, the collection function interface basically, overrides the toString and it makes it print just the collection itself. So in this case, the array list is what is overriding the function that's there in the object class. Let's go ahead and execute this. There we go. So I've inserted or added numbers 1, 2, 3, 4, and this is how the list interface is being implemented by the array list class, which is the concrete class, and this is the perfect working of it. Um, how about actually, you know, accessing an element? Let's access the data. Let us access this data. Number dot get to. Okay, we're gonna have to compile this again. Let's print this one. Yep. So you will have to pass in the index of what number you want to get, and that's how you access the element. So this we're passing index number 2. The indexing starts at 0, and 2 basically is like the third element. And how about we actually even delete or remove an element? So let's do it like this. Int remove number is equal to number dot remove 2. Let's do that. There we go. So it's removed 2. Now, if we print the list, we're gonna have 3 numbers now. It's gonna be 1, 2, and 4. There we go. Initially, we had inserted 1, 2, 3, 4. Then we accessed the second element, which is 3. Second, as in the third element, index number 2. And then we deleted that, the element of index number 2, which is 3. And finally, we get the numbers which with the removed element, like, removed. Now, let's talk about, the differences between the list interface and sorry, the array list and list. So basically, an array list is used to help you implement resizable arrays in Java, and it's better for storing and accessing data. Linked list is basically a doubly linked list, used to store elements, and it's kind of faster than the array list, and it's better for data manipulation. If I have to just again implement a linked list, it's almost the same. Let me comment this part out. List string F1, that's my favorite topic, is equal to new linked list. F1 dot add one dot add Red Bull. Ferrari. This is my favorite teams, and so let's actually print this out. And then after this, we'll move on to the stacks. Yep, there we go. So a linked list functionality is almost the same as an array list. It's just a lot more faster because you're using a W linked list, and the accessing is far more superior. And it's used for a lot of manipulation and rather than a simple data access and inserting and storing, which is more for the array list. Moving on to the queues. Let me share my screen just once. So the array list is again used to implement resizable arrays, and linked list is used using just a W linked list to store elements, and it's just a faster access than the array list. Now moving on to the stacks, we're talking about a last in first out data structure, wherein you're using actually a vector for this. A stack basically is going to um, extend a vector class, and vector class implements the list. That's how the hierarchy is. But if you just check this out, I've actually put the hierarchies on the right, and I've made it specifically just for array list and stack. The one for linked list is the same as array list. It's exactly the same. This array list is going to change to linked list. Basically, stack extends a vector. This stack class extends the vector class, and the vector class basically implements, or in that way, I think even stack also implements the list interface, and this list interface can extend the collection interface. That's how it works. If we talk specifically about stack, let's start coding again. The most important concept to be kept in mind is about wrapper classes and um, the way an interface in a class works. That's the main ideology behind this. That's super important, because otherwise this chapter is super easy, barely an inconvenience. And in application wise, it's even more easy and makes our life far more easier. Let me share the coding screen again. Sorry. Okay, so let me just comment this out. So before we actually include stacks, what's the most important thing? It's the import. That's when we can utilize this facility. So in order to create a stack, we must import the java.util.stack package first. And once we import this package, we can create a stack. So let's do that. So now let's go ahead and create the stack. I will create a stack of type string. I'm a huge animal lover, so let's create an animal stack. Now, the set of operations that we're going to perform on a stack is super important. We're going to have these set of operations. So operations like empty is obviously going to be, implemented from collections or even the list framework. But then When we talk about specific functions as defined within the stack class, we're going to be talking about the push, pop, peek, and search. Search is again a very common function, so it's used in many it's used in many objects. So that's again a very common function that's common to all sort of thing. But we're talking about the push and pop and peek, which is specific to stacks. So in this, let's actually push a few elements, shall we? Um, Animals dot push. I'm a huge dog lover, so let's add that to the list first, followed by all the cat lovers. So let's push in a cat as well. Lion King is my favorite movie to date, so I'm gonna add in lions as well. All right, so let's go ahead and actually see what the results look like. Although when you look at this kind of specific case, it looks like, what's the use of this? Because almost every set, like, even an array or a linked list, array list or a linked list also looks somewhat similar. What's exactly the use of it? If you ask me that question, comes to moreover the use in your final project, or the specific problem statement that you're tackling. Sometimes you might need to use a stack. Sometimes in your strategy you might need to actually include a simple array list. Sometimes you have to use a queue because you want to actually store that data, and immediately that has to first be processed rather than last in first out. Stack works like a pile of books. You keep piling books one on top of the other, but the first book that you're going to take in terms of pulling out books is going to be the first book first, the last book that you put, then comes the second last, then comes the third last. That's how a stack works. And as you can see, yeah, I have actually put in dog, cat, and lion. So the most recent animal that I've pushed into the stack is lion. So we're gonna have to see how peak works, which we'll do right away. And then we'll go ahead with pop. So only for your push, you will be actually adding a parameter, which is your item. But for peak and pop operations, you will not be using that. Let me start popping it off. Was the pop. Let's do that once again as well. So if we actually implement this, we're going to see first the line being popped off, and then we're going to see the second last animal, which is the cat, being popped off. So first we inserted three stack elements, which is dog, cat, and then finally we pushed a line. Then we got a peek of what's on top. What's the top stack pointer pointing at? So that's basically the line. That's the most recent element. And we popped off the line and then we printed the list. So we get dog and cat. Then we again popped off cat. Then we're getting dog. So that's how we get this. Now the next set of topics that I'm going to be talking about is, let's, if we go back to actually the set of interfaces, we've completed actually the list interface. Let's also be talking about even the hash interface. We'll just, the list was the main part. We cannot be talking about maps and sets because that's a separate topic on its own, and it's a huge and most important concept that's supposed to be taught. It's used in most of the coding tests, and companies like Apple and Microsoft suggest that students be knowing about the hash maps and stuff, because you're going to be using it in several concepts like dynamic programming and a lot of algorithms. So that comes in very handy. Let's just go back 1 second to our tree. This image will be found on Google, very common interface. So, this is the collection framework tree, and, list is an interface that we've completed right now. And we've talked about array lists, linked list, vector, and stack. Stack is what is extending a vector, and vector is a very simple concept, same as stack. Now, let's talk about a queue, a DQ, and a set, just very briefly. So basically, you have a queue interface, which is basically a first in, first out order, which is opposite to that of your stacks, and it is basically an ordered list that can hold the elements that is supposed to be processed in line. That is, it basically does, generally speaking, first in, first out. So whoever comes first, the first element will be processed first. So that's the way it goes. But so a priority queue, for example, implements is a class that implements the queue. And we'll also be talking about the DQ interface, which is basically a double-ended queue, which is, you can add and remove elements from both sides. So that's basically used to perform operations from both ends. And you have your set interface, which is again present in your Java or util package and extends the collection interface. And it's used to represent an uh, unordered set of elements, which doesn't allow to, basically, you want to basically have an ordered set of elements, unordered set of elements, which basically helps you to, remove all forms of duplicate items by all means. We can store at most, like, one null value in the set. Helps you have, if you studied if you come out of your 10th class recently, you'll be understanding that a set is basically a unique set of items. So that's exactly what's being done. So the set is basically implemented by hash set, linear set, and tree set. So let's just briefly try to go ahead with the programs. Let me share my screen once again. I'll share it to the coding interface. When we're doing very simple programs like this, it kind of seems almost as to why we're taking so much of leaps and steps to go ahead to do something such a small concept. But when we're using a large data set, and when we're working with huge amounts of data, it becomes very convenient to actually use these forms of frameworks, and it's very useful, like when it comes to the industry. Yes, so here is the screen for coding. Let's again go ahead and implement queues. And finally, a hash set, if time permits. So we're creating a priority queue, and we're just using the variable name queue for storing this list. So let's go ahead and add, right? Let's add people. Add Lion. Let's add some 3, 4 elements. Right. So here's the set of elements that I've added. I am going to print, say, the head element. Let's see what it prints. Hmm. So it's giving us cheetah. That's what it does. Let's also try printing teak. So basically gives you the head element. Yes. Your head element here is actually the cheetah. That's where the head is. Let's also actually remove one element. Let's actually print QNC. Although you're ideally not supposed to do this, you're just checking the queue. There we go. So this is how it's taking the QS. That is why it was printing the head as cheetah. This is why it was printing the head as cheetah. So the Q has taken the head as cheetah, leopard, lion, and then tiger. So it's taken it in alphabetical order. So that's why we're getting cheetah as a head. Now, if you think about it, it's going to process, suppose we're processing, suppose it's like an actual queue. It'll process cheetah first, and it'll process leopard first. It'll process lions, like, after that, and then finally the tiger. And basically, what it also does is we also have this priority queue, wherein it will get to know the priority of each member, and it will execute whatever functions accordingly. And that's an added advantage. Let's also look to actually remove or iterate through the elements. Actually, let's actually implement this iterator interface. Let us iterate through this. I've created an iterator. Yes. While, so this is the set of functions that we'll be using. First, we're checking, okay, does the iterator have, which is a queue right now, does it have a next element? If yes, okay, you know what? Let's go ahead and print it. Let's go ahead and execute this. So there we go. It's iterated through each and every element and it's printed it one by one. So that's how this code works. Let's also, do a remove operation and then let's do a poll operation and then iterate through this queue again. It will perform the following functions. This is how it will work. So your remove is to actually remove the first element that has come in. So in this case, it is cheetah. So you will it will first remove the cheetah element and then go ahead and execute the next. I am so sorry. It should work now. The editor always takes a bit of time to actually execute, but otherwise, that's why I kept some code ready so that I'd rather prefer the class to be a lot more interactive. That's why I wanted to type it manually myself, as in during the live demo. But sometimes you just have to keep stuff ready backward. So we removed we removed cheetah and leopard first. The poll is basically supposed to remove the second element as well, like. And now after removing the two elements, now we're just trying to go through the queue again, and we do realize that we are left with the last two elements. The stack, on the other hand, did the opposite. Whatever was pushed into in the most recently, that's going to be popped off first. That's how stack works. And queue, on the other hand, is a first in first out type data structure. The DQ is basically a double-ended queue, which basically helps you to perform these operations on both ends. That's why a DQ is somewhat important as well. You can basically let's create a quick DQ. It's very simple concepts once again. So here we're basically traveling through the list, which is the double-ended queue. Almost all of these implementations have the same mechanism for adding and removing and stuff. So that's the reason why we end up with a very. That's why this framework was brought into existence. Gautam Karan Energy. So that's how this works. So in terms of set interface, you can have a hash set class, you can have a linked hash set, you can have a tree set. So let's just talk about hash set just for now. So let's create first a hash set and add elements, and then let's traverse through that using the iterator. Works the exact same way. There is no confusion there, right? It's the exact same way. Codes can always be understood very easily, and there's a lot of resources for this everywhere today. There are so many slides, there are so many websites, there's even chat GPT that's come up. But what's important is to understand how these interfaces have been defined and how these classes are implementing it, and what classes do I need to use for my program. As long as you know that as a strategy, that's more than sufficient to actually work with this concept. Yes. So this is where we've got Vijay, Ravi, and Ajay. We have a hash set. So it basically, helps you just have a single element, which is Vijay and, Ravi and Ajay. So that's the main thing behind hash set. It's a set, right? So you'll have only unique elements. So I've inserted Ravi almost twice. Doesn't make a difference. Doesn't. Clearly doesn't. So this is the main concept. So let me see if there is something else to implement. There's obviously quite a lot in terms of having a complex set of operations and checking what works, what doesn't. Um, let's actually move on to an interesting concept, which is the why of this. Why am I learning so much? Why do I need to understand the working behind the framework and whatnot, right? So that's very important to know why this framework was brought into existence and why it's making people's life far more easier. This is a practical example. Um, I was actually coding on lead code. So this is a problem statement that I had to actually come across. Let me go ahead and share that question. So this is the lead code problem. You have the n queens problem. I'm not going to be talking about the n queens, how to solve this problem. Um, it's again, like it's a concept that you need to know, which is backtracking. That comes under data structures and algorithms, which can be talked about later. This is the n queens problem, wherein you're solving n queens. So suppose I'm passing the number of queens in a chessboard to be 4. So it has to place 4 queens on this board such that it's a 4x4 board, such that no queens can actually cut each other. So if you see this example, actually they've provided the solution itself for n is equal to 4. So you're placing the queen in the second column first, followed by the fourth column, or it could also be the first column. So you have two solutions, potential solutions. And then the third one will be placed in the first column or the fourth column, again, depending on which solution you're taking. And finally, it will be in the second or third column for the last row. And it does this by backtracking, as in it goes through each and every place and places the queen and sees if it cuts or not. So that's my algorithm. If you look at the solution here, here is my solution. This is the main function that's been asked and that's been provided for the coding question. And these are all the stuff that I had to create. So first I created a queen to just convert this board and to put ones wherever there's a queen or not. And then I checked if it's safe. This is the algorithm to check whether it is safe to place the queen there or not. And if it's safe, then go ahead and change it to 1. Otherwise, change it to 0. And this is where the array list from the list is being used. So I've created a list of strings, and this is where I'm going to display my output. Now I don't have to worry about, oh my god, I have to create a string array or a character array, and I have to store a queue here, and let's store an array will have a specific set of requirements. So I'll have to mention, okay, create an array of size 4. Here I don't have to do that. I am free to add and remove elements as and when I want. So here basically, if there is an element, if there is a queen, then go ahead and I'm going to print a queue. Otherwise, I'm going to print a full stop. And you're basically adding this variable here, which either stores a queue or a full stop. And you're adding this list, this set of elements. This list will be stored in another array list. So that's how it works. Let me go ahead and execute that code. So the display function is where I actually implemented the array list, and this is where the collection framework kicked in and helped me go ahead with this project. Let me just execute the code just once. But this shows the why of the collection framework as to why am I actually executing this. Let's just go ahead and execute this. Right? So here are the possible solutions. It's the same thing which has been printed. The Q is on the second one, second column for the first row. And in the picture also, it's basically the same thing. And for the second row, it's on the last column or the first column. It's the same solution. But like the main point being, the way I've used array list for this makes my life far more easier. And the data structure which is returned is also list. What makes list even more convenient is the way you can actually print this. It overrides the toString function which is defined in your object class, and it overrides that function to make it just print the contents of the list as if it were a string. You can clearly see that this is a collection here, right? This list of string is a collection. It's not a string. It is not a string at all. And yet, so conveniently, when you're doing the system.out.println numbers, it's printing as though it were a string, from the very beginning. So these are the sort of functionalities the collection framework gives you, and a concept that's super important, makes your life far more easier, and making, it helps you making, solving this set of problems almost like, very easy, barely an inconvenience. So I really hope you like the assignment, and looking forward to creating more classes and more content.